Well, good morning, Professor Xing. Good morning, Eric. We are in Abu Dhabi in Masdar city together, and I'm visiting you at your university, University of Artificial Intelligence, named after Mohammed bin Zayed, the president of United Arab Emirates. And I think it carries the name of Mohammed bin Zayed most probably because Mohammed bin Zayed was the one that had the initiative of creating this university. It's a unique university. There are not many.
It is. It is the only and the first university of artificial intelligence in the world.
So I have just this feeling that there will be more. So you'll be also remembered.
I came from a place where in Carnegie Mellon we found the world's first department of machine learning. And now I'm leading the university, which is the first for AI, which is a very interesting path. Yeah, we want to be in that position to contribute to the field.
Oh, yes, fantastic. To be a pioneer of something is always not only historic, but also give me great pleasure because you are going through unknown. Nobody has done it before you. The others will come, probably they will improve something. But the pleasure of creation, something is wonderful.
Thank you.
And we had a short meeting, and in fact, I realized that we both have several things in common. We were both born in communist countries. You were born in China, and I was born in Soviet Union. I think we both like mathematics and logic, and I found out with pleasure that you also like classical music.
I do.
But today, I think it will be very interesting to hear from you about a bit maybe about the past, about today, and about the future of artificial intelligence. And this is where we have to have this dialogue. And specifically, because our conference in Singapore is focusing on life, health, well-being, longevity, and I'll appreciate your opinion and your views on that.
Thank you for this opportunity. Yes, I think in the past 60 or so years, artificial intelligence has really evolved from a very small engineering and mathematical branch now into a foundational discipline that is touching almost all the aspects of science and life. I want to compare that to maybe something like the future version of mathematics, but with the extra capability of automating and operating, devices and solving problems. So why is that? Because artificial intelligence, if you see its evolution, it actually went through several waves of up and down and recreated itself, out of the past multiple times in response to the available theory and the technology at the time, and also the problem that people want to solve in a very, very iterative and a proactive fashion. I don't want to spend the time to go through the history of the AI, but the modern day AI is actually a combination of mathematical principle and also a heavy use of data-driven empiricism to create something based on a connectionism philosophy and implementation. And that's where you'll see what we call foundation models, that is underlying the large language models, powering GPTs and other functions. It is really leveraging on an unprecedented combination of the amount of data, the amount of compute, and also novel algorithm and computing hardware innovation all put together in the same place. That actually enabled the modern AI to solve many problems in a way that is becoming unfamiliar to our human logic and reasoning. For example, we see ChatGPT start to show what we call artificial general intelligence, meaning that it is able to solve problems, answer questions, creating contents, and so on, which were previously considered to be the privilege and the expertise of a human being. But on the other hand, if you look into how such capability were achieved, it is not using the way that we human typically do, right? Human being can learn from small amount of data and also can leverage on multidimensional sensory, like your eye, your ear, and every other feel and everything to help with reasoning. And also, human brains are very energy efficient, in sifting through information and find the optimal solution. These are not the way a computer or a GPT model use to solve their problem. They use a very heavy amount of computational resources and a large amount of data to absorb information and to categorize information and organize them and also transform them into a new representation that is good for machine, not necessarily good for people. So in some sense, it is artificial intelligence. It is not the intelligence that human has. So sometimes it is, we should ask, is that even appropriate to compare a artificial intelligence versus a human intelligence? Just like, is that right to compare a car with a human when they are running, right? There are two different capability and two different implementation that are not supposed to be compared. The latter, the artificial one, is created by mankind to achieve a function, and our very goal of creating AI is to do better than human in some particular task, like creating contents, like answer questions. But the underlining, the silver lining of this interpretation of AI kind of also shed light to how you perceive the future of AI. Should you really be afraid of it? Or is that going to be going out of control to come after human being? Do you see, for example, a car coming after the horse to kill them? So philosophically, there is a gap, in drawing the conclusion that a smart invention, a machinery, will come after its inventor and destroy it. The same kind of a gap exists also in artificial intelligence versus human intelligence, because it is a piece of software. It is made to be powerful, just like a calculator, solving math arithmetic problems. This AI software is built and developed to demonstrate, a substantial amount of intelligence in the form of knowledge acquisition and the knowledge offering. And in the future, it may also be turned into solving difficult problems, which probably requires next wave of new innovations. We're not there yet, but after all, it is created, by, a human being, by a living creature that has even additional dimensions that is not implemented in those machines yet.
Of course. I think that's fascinating. But you were speaking about sort of evolution, how we came to this point, and personally, I have the very positive story of history of my own evolution. I started as a theoretical physicist and mathematician. Much later, in 1985, 84, I was doing research on theory of relativity, relativistic astrophysics, theory of gravitation. But eventually, in order to solve the problems, I found out that there are no ways that analytically a lot of things could be described. That's why you needed the support of machine. In this case, was a computer. In this case, it was an ugly machine, which was a mainframe machine, and you had to go through a very difficult process of writing a program, like say in an assembly of Fortran, put on the cards in a very noisy environment. So the department was created, and when I created the department, amazingly, a lot of students from the big department of physics in Yerevan State University, a lot of them wanted to come to that, to be students at that department. By their just feelings, they were feeling that this is something of the future.
I remember when I was an undergraduate in China, there is a computing center for the university. We need to reserve like 30 minutes, every week or something to go there, test run a program that way, right? It was a precious resource, but it's powerful.
Yeah, but you raised an important questions about should we fear artificial intelligence or not. I think it will be interesting to know a bit more about your opinion connected with this issue, because it's very, very it's growing very fast, the fear of artificial intelligence. While people, I don't know, take it for granted as a normal. If they have a question now, they go to Google. They are not afraid that Google is smarter than them.
Yeah,
They
it's supposed to be smarter, right? Otherwise, you don't
They
go.
are.
Yeah.
Google is smarter than them. In fact, whenever in a dialogue somebody is asking me, "Do you know when this country was founded?" Even if I know, I'm not answering it question. You know why? Because sometimes it's embarrassing. The person asks you the question and then takes the phone and does the Google search.
I think people oftentimes confuses being knowledgeable versus being intelligent. That's two different things.
Yeah.
Right? Google is very knowledgeable. ChatGPT is even more knowledgeable. But intelligence is a different dimension. It's a capability from a different dimension. It's about using the knowledge to solve many problems, including raise the problems, define the problems. And you are a physicist, and I used to also work on physics and biology. The hardest part of science is to turn, a empirical needs into a technical problem and formalize it, and then turn to a computer to ask to be computed. That part isn't what a machinery is told to do or trained to do, and that's where human has a unique advantage and privilege. I don't see that now version of artificial intelligence is going that direction, and I kind of sense that I believe that even in the future, we are turning machines into that capability. It will take ages to get there because there are fundamental gaps in terms of the mathematical tools, in terms of computing resources and the data required to achieve that function. So talking about fear, I'm more fearful of the person who uses high technology, advanced technology such as AI, but also say nuclear weapons, chemical weapons, and biological weapons, rather than the science itself, biology, physics, and chemistry. And the AI is a science. Right? It is not a device or a creature that is scaring or intimidating people.
Yeah, I think your point is very clear, and it takes us back. We cannot condemn nuclear physics for creation of nuclear bomb and using it. We cannot condemn biology or sciences related to DNA and further for the biochemical or other weapons connected with biology. It's unfortunately not the artificial intelligence that is doing the wrong things and wrongly using the advancement of science. Is the natural intelligence of ours.
Yeah.
And which is behaving a sort of unhuman. So being afraid of artificial intelligence for the moment, at the end of the day, is a mathematical code or a software which is created by humans and it's controlled by humans, cannot be dangerous. What can be dangerous one day if the natural intelligence will use wrongly the artificial intelligence.
Yeah, I
right?
really like the way you put it. Yeah, natural intelligence complicit with artificial intelligence, to do harmful things. That's possible. But of course, also I want to point out that compared to other disciplines, artificial intelligence is still at its dawn. It's not that powerful yet. We want it to be more powerful down the road. That's why where is the priority at this point for the science? Putting together over-regulation or over scrutiny to even say stop or slow the advancement and the innovation now, or we want to see further developments? That's actually a question the society and the policymakers should think and answer.
Yeah. But before going to our main theme that I would like to discuss with you about artificial intelligence and health or life, health, well-being, longevity, how artificial intelligence can improve or help us to live healthier or live longer life and better lives, both in countries that are very developed, rich countries, or also very important in the poorer countries. But before that, I would like to discover together with you discover things connected to scientific research. Somehow, when we were speaking about artificial intelligence today, reminds me when people were discovering quantum physics, it was so absurd, it was so different logically, that if politicians would have understood a little bit of quantum mechanics, probably they will try and they will start and try to regulate quantum mechanics. But the discovery of quantum mechanics unregulated freely by free thinkers, different thinkers were not thinking classically, thinkers that were challenging the whole logic and philosophy of science and classical mechanics, had created the new society that we live in today, and had created the foundations of quantum physics and nuclear physics, and eventually created the possibility of harnessing the nuclear energy, but also creating the bomb.
Yeah, absolutely. Yeah. The discovery of quantum mechanics actually is a fascinating example about how science evolved, right? Because I used to be a physicist, so I kind of know a little bit about that, right? Not everybody, including the top scientists, approves that, right? Including Einstein, who would say that the God is not playing dice with people. He would go with a more deterministic and a more rational view about the universe. And in his opinion, quantum mechanics is not in that kind of a track. But people didn't stop with such authoritative voice from a giant in the science, and allow the scientists to push further, eventually making quantum mechanics a fundamental cornerstone of physics in the macroscopic world. I want to emphasize this because every natural phenomenon has a scale. It is not necessarily following a universal, maybe there is a universal law to be discovered, but the tool we have now isn't necessarily automatically solving universally problems of all scale. I talk to, for example, my students that if you are solving the characters of a piece of metal or any kind of a macroscopic material, you cannot apply quantum mechanics because the amount of compute, and also the amount of information that you have to solve problems using a first principle approach isn't ready or isn't available. And then what do? You go through maybe an empirical approach that is appropriate for a problem of that size. That's particularly interesting in biology. Biology is dealing with a microscopic world and also a universe of a macroscopic world, which is patient and living creatures, right? But even for the microscopic entity like a DNA, it is not so small that you can apply a quantum mechanics to actually compute, what structure it will form, right? And that actually makes biology a super interesting and complex science that is not yet settled, on a very, very, how should I say, powerful research paradigm. I would say if you look at the history of biology, what is the greatest invention to date? I wouldn't say it's mathematics, or any first principle-based theory or paradigm. It is perhaps the microscope. Microscope is a very, very,
What about
mechanical tool.
What about the telescope?
Telescope for astrophysics, astronomy, maybe having the same rule. I'm not expert there, so I couldn't say that. But in biology, I think what really fundamentally changed, modern day biology is the microscope, starting from the optical microscope to later on electron microscope, atomic force microscope. They just allow people to see basically the entity rather than to compute, right? Even X-ray crystallography and nuclear magnetic resonance is a form of collecting observational data for you to compute. So biology actually thrives, on empiricism and observation and data rather than using a mathematical first principle. And we are at the juncture now that this empiricism has accumulated so much amount of data. It may be a time to ask, are we ready to revisit the idea of having a mathematical model, for biology, so that you do the science in a way that is closer to what we do in physics and in chemistry and in other science. People may remember when you watch the movie Oppenheimer, they ask, oh, when I explode the bomb, am I going to ignite the atmosphere of the Earth to create the disaster? Then someone went on and do the calculation. There is a mathematical model for the nuclear bomb and for many other things. That's not the biologists do biology. Biology is done by and large by trial and error, by experimentation. You put a piece of DNA into a vector and you inject it into the organism. You actually don't know what's going to happen, right? Or you knock out a gene. You also don't know what's going to happen. You have a piece of amino acid sequences. You actually don't know how to compute the structure of the protein using first principle. So that's actually the current nature of biology. Yeah. We want to ask, is that going to be still the case for the next 50 years or 100 years? Or we may be at a time to rethink whether a model-based biology is a possibility. So my personal conclusion is that we may be at that juncture. Because if you look at the artificial intelligence, the recent use of large language models, foundation models, is trying to solve the problem of AGI using a different approach. We are not mathematically derive what is to happen next, or what is the logic underneath human reasoning. We actually literally train very big models built on all the language information and maybe in the future visual information, and then build a model. You can call them remembering the information or organizing the information, but whatever happened, all this information gets sucked into this big model, and then something happened within the model that is known as the scaling law, also sometimes called a emergent property, that they brew themselves. It's like brewing the wine. Something happened in the model, that the information gets reorganized, re-represented. And then when you prompt this model, with a question or with a particular type of operation, they start to generate the content you want, say an image, an answer to your sentence, or maybe even an essay written in the form of a Shakespeare writing style and so forth. It is not done through a mathematical reasoning. It is done through pure computing based on a new organization of the information. I'm trying to see or ask, what if we apply the same rationale and the engineering effort to biological data? Maybe you can expect that once a machine is built on the totality of all biological data, DNA, RNA, protein structure, cellular information, it could be possible that you arrived at a model that is able to simulate you the biology, like what we simulate in the large language model. They simulate the next word, by and large. Here, how about simulate the next step in biological evolution or maybe biological function? So that's where I see the potential of having a foundational model, which is not built on physical laws, but built on data-driven connectionism to give you a power, in making predictions in biological phenomena.
Yeah, I think biology takes us to the new boundaries in some sense. We can come to that boundary from a different direction. For example, we can come to that boundary from physics and particle physics, physics that we are using clear laws of nature. We know how to describe that. It is mathematical. In many cases, we believe that analytical solution and analytical description is mathematics is the king. So anything there, we can just make a simple model, put that in a formula, and that's it, the model. The formula is the model. But with the complexity, when you have not one elementary particle, but thousands of them, or millions or billions of them, it becomes much more complex, and relations could become, and you don't have one or two types of relations, even with the same type of elementary particles.
Exactly.
For example, if you take the same two electrons, they basically sort of hate each other. But when you put in a special circumstances, they can create elementary particles that don't attract each other, that create couples.
Yeah.
We know even in our new classical quantum physics that is much more complex, like creating Cooper's pairs and so on. So the moment the amount of particles comes together, there's something that fundamentally changes how you describe that.
Yeah, physically they have phase transition, but even methodologically there should be a phase transition to use a different type of approach.
And I do agree with you. Probably the future of our research is not only going to be knowing very well mathematics, the laws of physics, biology, and all of the laws of nature, and using your analytical approach, but also trying to discover a new tool of research, which is basically based on computing or what you were describing now.
Yeah,
and of course we will not do that without artificial intelligence.
Yeah, that's where I see AI to have a very large role to play in the future of all sciences. It may become the modern day new mathematical paradigm, not using a single equation or a law, but using a data-driven big model to answer all the queries. But there's one caveat I want to really point out. AI, as I said, is a software. Therefore, all the functions that I just described and all the capabilities happen in a virtual digital space, not in the physical world. What's the implication? It's actually very important. When you experiment, for example, with chemistry, with biology, you play with dangerous materials, like bacteria, virus, poisonous chemicals, and so forth. And the risk of leakage, the risk of misoperation, is always there. And when they happen, it's very hard to control. I'm not saying that the digital simulation is not with a risk, but it's safer. It is still in the virtual world, there is an absolute barrier between the physical world and the digital world that you have to go into the nature to create a harm.
Yeah.
And in the case of AI, they give mankind or give operator extra checking points to put a plug and then to actually stop the risk.
Yeah, well, I agree with you. At the end of the day, you have to have barriers, or you have to isolate the environment or the space where you do the biological experiment. So there is a biological huge space, which is our planet, and we are the part of that. And if we do a biological experiment, we have to isolate it. I mean, 100% isolate that in order to avoid of any leakage, which in some cases could be uncontrollable and disaster. The same probably happens with the virtual space. If you are doing experiments or creating new software, which can be very powerful, probably you have to try also in the virtual space, which includes our life as well, isolate that laboratory from whatever is happening in the global network or softwares that we are using and or basically our daily life is too much connected with electronic networks. So you have to again isolate that in the virtual space.
Yeah.
But what you are saying is right. Between the material world and the virtual world, there's still this huge wall, which doesn't. One can have influence on the other one, but they are jumping from one space to another is difficult.
Yeah, people didn't realize that this barrier between the virtual world and the material world is a paramount one, because mankind, civilization can survive without a computer. You can actually literally shut everything down, our civilization will continue. But if viruses, nuclear bomb are out of control and really, really blow off, we're done. So it's a different magnitude of risk. One is making us less comfortable and less convenient. The other is more existential. So when I hear the existential risk of AI, I cannot kind of compare that with their counterpart of new technologies in the physical world. And I don't think they are at the same order of magnitude. And therefore, the public anxiety and also fear should actually be channeled into a better understanding of the nature of the technology.
Yeah, that's a very important point. And then I think it's also very important to realize that generally the world community is ready because of the virtual experience, because of the number of the films they watch every day. They are ready for conspiracy theories. Even what happened to us recently with the pandemic, worldwide pandemic, there were so many conspiracy theories that this was exactly what you were describing. This was in a lab somewhere, and of course initially they started because it started somewhere in Far East in China. That it was in a lab in China. It started, and it was a leakage of an experiment rather than something else. So we as humans are ready for that sort of a fear that there'll be leakage of biological experiment into humanity or the environment biological that we live. That could be disastrous. We do understand emotionally. Now then it comes to a very simple thing, regulation, because there's a lot of talk now about regulating.
Yes.
And artificial intelligence, fine. The question is how on earth you are going to regulate the artificial intelligence. And if we are speaking about regulation, then it should be global. You cannot regulate in one country. You cannot regulate in the United States while it would not be regulated in China, in Singapore, in Russia, or anywhere else. It should be universal regulation that we as a humanity move forward with the same speed. Otherwise, you regulate one, the other one just takes a completely irresponsible behavior. But that's also true for biological experiments. Somehow, we as humans had managed through diplomacy to negotiate, put some regulations or biochemical weapons and so on, which is great achievement.
It's great.
But I think we need further there.
And I think the successful regulation of, say, biological, chemical, nuclear weapons is because these technologies produced a demonstrated risk. And it is well understood in terms of what the risk is and also what the impact is. Therefore, it's easier to build consensus. And also, it is easier to set up clearly verifiable and operationalizable checkpoints. Why AI is not that case? Well, because AI is an abstract risk. I have to say that so far, you cannot name too many incidences where people are killed by AI, or environments are harmed by AI, right? It's all hypothetical or complicit with many other technologies where AI is a small component in that. And that makes the so-called AI risk less tangible and less measurable and definable. I think the call for regulation is a timely one, but I see the value of that call and that need to be more toward promoting global discussion and education and understanding about this technology before we jump the gun too early to stop the development of the science.
Yeah.
And I also noticed that in those discussions, there are less representations from the scientific community, the developers, the engineers, the scientists who are in the forefront of AI innovation. It's more driven by opinion leaders, policymakers, politicians, and other individuals who I understand that they have a compassion for the society, for the man civilization, but we need facts and we need rational reasoning and understanding about the subject itself. And that's where I see scientific inputs and evidence-based reasoning is very important in this whole dialogue.
Yeah, but I think for general population worldwide, I think the fear from artificial intelligence is largely supported with our experiences of hacking. I think a lot of people do think that artificial...
And hacking is a human intelligence.
Exactly.
It's actually the furthest from artificial intelligence.
Yeah, but the whole idea was, imagine there is not a 16-year-old boy from a garage hacking a major institution or blocking energy resource or blocking logistics and everything, but is by not 16-year-old boy or a girl, but a very powerful artificially created intelligence that starts hacking us. I think that the hacking is one of the core contributors to the fear from artificial intelligence. But let me come back to the main theme that I would like to discuss with you. It's about the very important thing, which is in order to understand that important thing, we have created science which is called biology. And that important thing is called life. And at the end of the day, as you said, we can live without computers, we can live without virtual life. And that life probably on a nice island without internet will be quite nice and healthy. But we are who we are, and we live in a society where both artificial intelligence and digital world are developing very fast. But we have to pay attention on life, because that's the main purpose of our concerns and our activity. We are thinking about the climate change. We talk about the planet, but in reality we speak about individual lives. Because we are not speaking about an abstract planet of climate change on Mars or Venice. We're speaking climate change on Earth that has huge impact on our lives, on health or our well-being or longevity and so on. So life is the most important thing in our life. And that's why I would like to hear your opinion about the developed new tool or the new space in our understanding in the virtual space, which is artificial intelligence and health and life.
Yeah, well, that's absolutely a question that I'm passionate about. When we talk about health, pharma, medicine, pandemic, and so forth, it is sometimes easy to forget that all these phenomena is actually a manifestation of biology. What is fundamental, in all these aspects? When you want to cure a patient, diagnose a disease, you want to develop a medicine, or you want to develop a antibody. At the core of this problem, scientifically, is to understand the biology beneath it, whether a particular part of your cellular organizations gets impacted, whether you had a mutation that is causing malfunctioning of your body, and so on, right? So there is a unifying foundation, which is biology, to address all these problems. I think in the past, due to the limitation of computing, due to the limitation of data, scientists were taking really a very, very dramatic divide and conquer approach. That's why you see in a hospital, you have a division of liver, division of brain. Every organ defines a division. And then in biology, you see biochemistry, microbiology, plant, animal science, and so forth. Everything is divided. So this whole field of life science is characterized by siloness, that everybody is taking a particular part of the phenomenon, a particular kind of interval, in the whole spectrum of the data to solve the problem or to understand the problem. And you can imagine what the outcome could be, right? The outcome is a very ad hoc and empirical one that is sometimes working, but oftentimes either not working, or are not sustainable, too expensive. I think AI provides an opportunity for researchers and society to resort to a different philosophy and approach, which is about connecting, the silos and look at the problems more holistically. For example, to understand a disease, you don't have to limit yourself only through, say, biomedical imaging, taking, an X-ray, or do a ultrasound or, CT. You can actually go all the way down through, cellular morphology, protein malfunctioning, and DNA mutations, and all that, and then put all this knowledge together as a continuous pipeline, and then understand the issue and the treatment and all the preventions holistically. And that actually provides the opportunity to address some of the pressing issues now we want to address. Personalized medicine, for example, longevity, and even revisit our practice of medicine. One of the practice that is very commonly known in medicine is the FDA-defined drug trial and so forth. The fundamental hypothesis behind the drug trial experiments and design is that the drug should not produce side effects among certain amount of individual. It should work universally for a cohort and so forth. But this is actually fundamentally against biology, because in biology, every individual is different. They have their different makeup, they have their different lifestyle and environments, and some medicine which work for a particular individual, naturally does not work for the others. And that actually has both technical and economical impacts. We talk about, for example, these days, drug repurposing. People already find that a drug that is not designed, like Viagra is one example, right? It was not designed, for what is being used now. It was designed originally to address a heart disease problem, right? But they actually could be used for cure other type of diseases. But in the past, we discovered all those by luck. With AI, by understanding individual characteristics and also the anatomy within the biological level, understanding, you can actually compute and predict, personalized effects, at a highly repeatable and quantifiable fashion. And that actually opens a new opportunity and a front for medical science and biological science playing in sync, that you dramatically can reuse many of the existing medical and pharmaceutical results to address, existing challenges in healthcare, but also down the road, when we develop solutions in healthcare for larger scale problems like pandemic, or smaller scale problems like personalized health management, I think this type of a new paradigm gives you a new option to use the data and also to come up with a different type of operational mechanism and administrative mechanisms of public health operations.
So it's interesting because you touched the core of the problem, because artificial intelligence definitely can be helpful in resolving a lot of problems, be that mechanical, managerial, be that even
Yeah, maybe if I
organizational,
may,
logistical, but you went up to the core of it,
yeah.
how artificial intelligence could help when we're looking to the core of the disease and understanding and basically connecting the individual.
The connecting is very important. If I may, I can use maybe an even more accessible example. Why we prefer to see a doctor that is old and really had tons of experience of seeing thousands of patients. Well, the reason is because that doctor have successfully treated so many patients, you have the trust that he can extrapolate that experience to me, but maybe having a unique kind of understanding about me and my needs. But you also may expect that among the few thousand individuals he or she saw before, I may be similar to some, right? But if you rely that on a human, how many you can expect even a very accomplished doctor can see in his past? Maybe thousands, maybe tens of thousands. But imagine that the AI provides you the potential of seeing millions, if not billions, of patients, in a single database. Right? That's the kind of a new capacity which was never imaginable, before the age of AI. So, in summary, the AI is built, very heavily on human experiences, but it is really trying to build connectionism between all these siloed parts of knowledge, not only among instances of individuals, but also in terms of granularity from organism to molecular to submolecular level. And that piece of connectionism and also holistic view, in my opinion, will fundamentally change the way we practice medicine.
I think that's quite an optimistic approach to artificial intelligence. We started talking about the fears of artificial intelligence. It's also the time to understand how much artificial intelligence can do good in our research, fundamental research, and even daily managing our lives. And we have already gone through these sort of stages of fear. I do remember when the first personal computers were arriving, there was a global fear that millions of people will lose their jobs because they were accountants and using skills in order to do accounting. In reality, the computers created millions and hundreds of millions of new jobs. I mean, that restarted or rediscovered our modern life in a completely different way.
Yeah, absolutely. Jobs, is a fluid existence, I would say. In the good old days, I remember I went to the British Museum, and one of the famous artifacts is this scriber or the bookkeeper in the Egyptian, society, right? Copying and writing is one of the major job, white collar, I would say, high class job. But now, even typist is not needed because we have new technology that handles that kind of job better, more effectively. And then people will be free to do other things. Again, same thing like after photography is invented, I guess painters who does portraits may feel their job are in danger. Some of them may lose their job. But look how many new photographers we produce, like the gentleman standing here, right? With computer, with AI, we cannot even imagine how many new opportunities and jobs can be created. But my prediction is that it will be more than the job being lost in the current state.
I think the world that I liked in your description is looking at things holistically, and that's very important, not only in space but also in time. And from that point of view, photography has created a completely new type of art, which is photographic art.
Yeah.
And the same people with the same photographic machine, different people create different pieces of photography, and some look absolutely brilliant and beautiful as a piece of art, the others look so regular. But if you take this holistic approach, it takes me back to Armenia, where we have a unique institute of ancient manuscripts. Armenians are the first nation, as a state to become Christian, and we embraced Christianity. A new alphabet was created in order to accommodate the new religion in the year 301. And how do you basically teach people or distribute the ideas of Christ or Christianity? It's not only by word but also by written word. And of course there were no computers, there was no internet. What was happening in all small monasteries, one of the main tasks of these monks there was just copying a Bible.
Yeah.
And with the time, copying a Bible became an art, because they were not only just copying the words, they were copying artistically and putting that beautiful the drawings, and then the drawings became even beautiful paintings inside the book. And without, for example, in Armenian church, we don't have icons. We have but illuminated books, and we call them illuminated because they are artistically done. And there were great artists of the medieval time that were basically writing a book, but as a book which is a piece of art. Or if you take 1 or 2 pages, they are as beautiful as the paintings of Renaissance time. So just copying it had lost the meaning of being copied.
Yeah.
And became a piece of art. So the world is fascinating, it's changing. I think the thing that I am happily taking from my discussions with you, Professor, that we shouldn't be afraid of artificial intelligence.
Thank you. Yeah, I truly believe that there are more opportunities than risks.
Yeah, thank you very much, and I hope that we will see you not virtually but physically in our next conference next year, because I do believe that the issues that we're discussing about life and its connection with the space, the material space, with biology, with science, and with virtual space, and specifically with artificial intelligence, is very, very important. Thank you very much.
I look forward to coming to your event. Thank you very much.
Thank you very much, Professor.